Hello and welcome to Geometry. Today we've got a rare 2-for-1 special. We're in section 3.3 and we're going to solve problems 24 and 29. First, problem 24. So, we have a triangle right here and we're given that the altitude of an equilateral triangle cuts the base in half. Use this fact to find a formula for the area of the following equilateral triangle in terms of S. Okay, so what we've got here is we've got a triangle right here, and we're going to have to find the area of this guy, and we need to do it in terms of S. We have S over 2, we have H, but we need it in terms of S. The area of that triangle is 1/2 H S over 2, or SH over 4. So what we want is what H is in terms of S. Now to find this, we're going to use the Pythagorean theorem. We know that S squared is equal to H squared plus S divided by 2, parentheses, very important, squared. S squared is equal to H squared plus S squared over 4. Subtract this from both sides, so we'll have S squared minus S squared over 4 is equal to H squared. This is 4 over 4 S's, so we're left with 3 S squared over 4 is equal to H squared. Finally, we're going to take a square root, so we'll have S square roots of 3 over 2 is H. So the area of the little triangle, that right triangle, this area, is S times S square roots of 3 over 2 divided by 4, which turns out to be S squared square root of 3 over 8. And then the whole triangle here is just twice that, so the area of the big triangle is S squared, the square root of 3 divided by 4. Alright, and that's that problem. Next, problem 29. So this right here is a proof of the Pythagorean theorem. Yeah. And we're going to have to go ahead and show that. And the way that we're going to do that is using area. We want to find the area of this little square here. I'm going to call that A1. We need to know the area of these triangles, a triangle, and the area of the big square, area big. Area of the big square, side length is C, so it's C squared. The area of one of these triangles is, let's see here, it's 1/2 AB. AB. Okay, now the problem that we're going to run into is the area of this little square, because we don't know what the side length here is. We know that from here to here is length B. So that's like one side of the triangle, length B. And then from this corner to a point right about here, right where the square starts, is length A. So this right here, that's going to be B, the full length, minus how much of it is taken up by the other, by this portion. So B minus A. So area 1, or area L, is B minus A quantity squared. Okay. let's expand this. We're going to get b squared minus 2ab plus a squared. Cool. And before we scroll down a little bit here, let's just take note that there's 1, 2, 3, 4 triangles. So we're going to add triangles. And the little square. And it's going to be equal to the big square. Oops. It's going to be equal to the big square. 4 triangles. So the area of all 4 triangles is 4 times 1/2 AB, which is 2AB. And let's take that sum right there. This is going to be 2AB plus, if you remember, b squared minus 2ab plus a squared. These cancel. Positive 2ab, negative 2ab. We're left with b squared plus a squared, and it's equal to the big triangle. What's the side, the area of that big triangle again? Oh yeah, c squared. A squared plus b squared is equal to c squared. QED. Excellent. Thank you very much for watching. I'm sorry my handwriting was a little shaky here. My tablet's giving me some issues. Until next time, happy geometrying.